Hi, my name is Víctor de Lorenzo, and I am the senior co-author of a paper that I have written together with my colleagues Manuel Porcar and Antoine Danchen. The starting point of this work is the question of whether we can employ synthetic biology to engineer biological systems with a degree of predictability and reliability similar to that engineers are used to. For instance, once we have a metabolic network or a genetic network, can we enter a new component of that network easily? Well, in the work of engineers, it has been known for a long time that having standards is one of the bases of having a reliable engineering agenda. But it happens that in biology, standardization is not as easy as in the case of engineers. For instance, the typical materials that engineers do have to do with hard stuff, with metals, with pipes, with tubes. In the case of biological systems, what one has is basically glues, elastomers, and sticky things. So obviously that means that you have to rethink a little bit what is the basis of the standardization attempts that we wish to develop for making synthetic biology a reality. The basis of engineering is standards. Standards allow different people to work together, allow different people to collaborate, and most important, it allows to fit accurately one object inside the other. However, in the case of biological systems, the issue is not as easy, because the most we can do, and this has been done successfully in a number of cases, is to develop standards for physical assembly of DNA. However, it happens, everyone knows that physical assembly by no means signifies functional assembly. And in biology, what is important is function, not so much structure. So various standards have been proposed by different laboratories, by different communities, on how to put together different DNA pieces, and it's everyone's experience that hardly this physical composition results simultaneously in the merge of the parameters, in the merge of the various functions. So we wonder how we can tackle this very important bottleneck in synthetic biology. And the type of inspiration that we had came from the work of architects and engineers of the 19th century, in particular the Spanish architect Antoni Gaudi, that was able to construct this beautiful building, the Sagrada Familia Cathedral in Barcelona. So by that time, they had no advanced computing, no advanced simulations, very little mathematics, very little capacity to deal with complex constructions. However, he was able to solve the problem. How he was able to do that? Well, he developed this thinking that can be called string weight engineering. And the idea is that when you have to design a complex object with a degree of multi-scale problems, then you have to consider nearby interactions. You have to consider also that the whole object puts pressure, individual components, and you may not even know all parameters involved. However, by having a smart use of gravity, he was able to construct a string and weights model that interrogated nature about what were the best parameters to get to a given solution to this multi-scale design challenge. And eventually he was able to build this building simply using the parameters that nature gave to him. So by the same token, and this is something that is explained and discussed in detail in this paper, we argue that the best way to engineer biological objects is to arrange in a logical way all the components, the parts, the devices, but then let nature to make the fine-tuning. And to do that, we may have to rely on evolution. So the proposition that we make is an invitation to the community to think on new assembly procedures of DNA parts in such a way that once they are together, they are allowed to explore a solution space and find eventually a good solution for the construct. So I hope that you enjoy the paper, and you are very welcome to feedback its content by either email or Twitter. Thank you.